me for putting all together and for the opportunity to discuss on all the inputs. Let me try to introduce what the MARE project is. It's a project that started in January, so we are less than close to the first year of the project. So we are still running this sort of theoretical approach for many ideas that should be brought in by the project. But basically, let me try to show you what the main ideas for the project are. So first, the main objective for the project is to provide this sort of reliable 6G services on top of the 6G infrastructure, and we plan to do it basically developing and designing and developing the concept of the security plane, right? So rather than going for something that is specifically customized to specific attacks, we are building a sort of open framework that is this security plane that is built on top of what we call security functions, such as translating from the idea of or benefiting from the idea of these network functions design. So the idea is to create these sort of security functions that are, at the end of the day, as a set of or a programmable set of functions that should be designed on demand according to what the specific attack or specific incident is, right? This is for sure is benefiting from what is already done in 5G, so it would be then easy for this transition, sorry. And then the other one is on the main contribution. So we have, say, two main contributions. The first is this set of enriched security functions that are building all together the security plane. And the second one is an extension of what Fabrizio was mentioned before on this pre-assessment framework using digital twins. That is this sort of pre-assessment ecosystem, but extending what we already did in HORSE. The idea here is to use not only an emulation scenario, but also a simulation and emulation and real infrastructure scenarios where we may test wherever that is running. So that's the main idea. So where do we deploy that? We all know that one of the, say, uncertainties that we have is that the 6G architecture is not, say, completely set in stone in the sense that it's an open and ongoing effort. So, but the idea in this case, in any case, is that the concept for this security plane is that it may manage whatever security components is to be or should be covered in any of the potential description of any of the potential layouts for what the 6G architecture should be, right? This is just an example of top of the X6, but it could be deployed to wherever, whatever block that requires security, because at the end of the day, we are softwareizing the solution, right? So the concept, as I said before, the concept is based on defining the security function, the security plane that is built on top of security functions. But how do we do that? Traditionally, the idea that we are using, in cybersecurity in general, is that we are providing security solutions that are customized to any specific attack. So at the end of the day, we have different attacks with different solutions. It's difficult to have correlated version of this solution. It's difficult for them to share, to interoperate. So it's not easy. At the end of the day, they are somehow managed. They have CM, whatever, and this system is responsible for managing what the inputs and outputs would be. But it's not that kind of, say, interoperability, right? So moving behind that, the idea is to softwareize the concept, right? So the idea is to create something that is completely open, programmable, modular, adaptable. It can fit whatever we want, right, at the end of the day. So, and to do that, as I said before, we plan to deploy this set of security functions, but this set of security functions should be created from somewhere and from something. And this somewhere and something is what we call dots. And the paradigm is connecting the dots. At the end of the day, what we have is a set of dots that are defined as a set of security assets. This set of dots should be properly composed to generate security functions. And the security functions generate a set of security functions, repository of security functions that once orchestrated will generate the security plane or the different functionality or services that the security plane can offer to mitigate and to prevent attacks to happen, right? The other concept, as I said before, is that we are building this pre-assessment environment, right, where we may manage through a sandbox, we may manage how this impacts, as Fabrizio was mentioning before, how the impact is somehow managed, is somehow, ensured, right, or warranted that we are. At the end of the day, the idea is that we are not depending on something that could be even worse for the infrastructure, that keeping the attack itself, right? So that's the idea. Because look that, it's also clear that we cannot go for something that is reactive, right? That's why also one of the reasons for going for this probability aspect. We cannot go for something that is completely reactive because, we cannot wait the incident to happen. We must be proactive in the sense that we may try to estimate when an incident may happen and they try to fix a solution or try to provide a solution to prevent the attack to happen. And that's why this sandbox scenario is very useful. So the concept of dot security function is, conceptually could be sexy, but at the end of the day, we should look for how do we do that, right? In MARE, we start identifying dots in terms of, say, groups of dots, right? Clustering what a dot could be. And we identified just the starting point 5 different sets, this assessment format, detection, CTI you see here. And we consider different, say, assets, security assets that could be dots that, as you see here, are also linked. Most of them are linked to specific partners that are in the consortium that can provide these tools. The idea is that we warranty that wherever that we consider in the project that should be an asset could be provided by the project itself, right? So you should not rely on something external, except when we are using these tools for monitoring that we may use tools that are widely accepted and easy to run. That would be from the point of view of the dots. So what would be the security function? Security function is just a set of putting together these dots, playing with them, orchestrating, composing, combining, right, to create specific functions that can manage potential incidents that we may have, right? And that's here, you may see a list of potential security functions that was written at the very beginning of the project that, of course, could be or would be extended and enriched within the project. Okay, the other point that is also different in MARE is that, we do not rely on real use cases because actually, we are also facing this problem in HORS that at the end of the day, we do not have a SIG infrastructure to deploy. So it's difficult to see how we may improve how this works if there is no SIG infrastructure behind. So rather than going on that direction of specific sectors, specific use cases for specific verticals, we decided to split the potential attacks into areas, thematic areas. And we identified these 5 thematic areas. The first on talking to or related to disaggregation, the second one on intelligence, the third one on resources, the fourth one on openness, and the fifth one on systems convergence. And for each one of the thematic area, we identified potential attacks that may come. And we end up with these 11 attacks that are described here. This would also help to identify what the 6G attack surface would be, because it's clear that as long as we are adopting new technologies, as long as we are adopting new components in the 6G architecture, new vulnerabilities will come up. So at the end of the day, it's difficult to find out what would be the real 6G, the real attack surface that any security provisioning solution should deal with, right? So what we propose is to generate these attacks as a specific attacks for each one of the thematic areas, and we end up defining these attacks, specific attacks, just for demonstration as well. So we built 11 POCs, each POC referring to the attacks that are listed in this table. At the end of the day, this is just a first pass. I'm not going to say for sure because I cannot say that, but most probably this list will be extended with additional attacks. So regarding the architecture is basically, I'm just going that very quick. The architecture is this one. This is a high level description of the architecture. It's basically split into 3 blocks: abstraction, the core, and the interface. The abstraction is including 4 blocks, as you may see here. The first is trying to identify what would be the attacks that are potential attacks that are defined according to the vulnerabilities the system may have. Then responsive for telemetry, responsive for systems characterization and aggregation. That would be the information that would be delivered to the cybersecurity core, and the cybersecurity core is built on two sides. The first is what we call the CEPE, that is the security and privacy engine that is responsible for, including these three blocks that are described here, and is responsible for managing with the dots, is responsible for managing with the security functions, building them, and it's responsible for generating the orchestration that is needed to put the security to develop the security functions in the infrastructure to mitigate, to prevent the attack that is going to be protected or predicted or detected. At the end of the day, this separate component is delivering an action that is the recommendation that the CEPE delivers to the infrastructure, right? But as I said before, and this is something that is extended from the HORSE project, we are also providing this PASTE component that is the one that is responsible for running the pre-assessment and validation. And as Fabrizio was saying before, we also have these two focus. One that is on analyzing the impact an attack may have, and the second one that is analyzing the impact potential mitigation action or preventive action may have on the infrastructure, right? And we could do that theoretically, we may do that in a simulated, emulated, or real infrastructure scenarios. And on top of that, we have the interface. The interface is the one that is, for sure, is just easing the interface with the system, and it's based on these different components. We start with this security SLA that is somehow defining the agreements regarding to security. Then we have the APIs, we have the dashboard, we have also the service repository, that is what we offer outside. And then we have also the IBN, the interface network manager, that would be the one that somehow facilitates integration with human and a more, complete understanding on what's here. But the point now, what we are now in the project, I said before, it could be nice to use this concept of connecting the dots, and we have dots, we have security functions, but how do we do that, right? So the first point is, what's a dot? Because it could be whatever we want, right? So at the end of the day, we are defining. MARE is defining the word, so the dots. So we may say that a dot is whatever we want. So at the end of the day, a dot would be a security asset. So we must characterize, we must categorize, and we must catalog them, right? The second one is, if we are using security assets that are outside MARE, we do not create security assets. For sure, they should be compatible. So the question is, are all them mutually compatible? No way. So we should find out a way to make them to be compatible. So we may generate exposing APIs and to generate also some compatibility matrix. The other one, is there a fixed set of dots already set? Not at all. It's a continuous effort, and the MARE project should even open the door to third-party developers to create new dots that could be included in this repository of dots. Is there a dot connector? The same, not set. Are dots reachable? They are discoverable and consumable. How do we do that? This is not set. So what is MARE proposing? MARE is proposing a sort of registry that it's communicating with a RESTful API outside, so the different dots could be exposed to the security function composer. So this block could generate and could create the security function. And the second key question is, how do we compose security functions, right? So here's a first preliminary pass on that. The idea is that we start with a comprehensive repository. This is this knowledge base that is adding metadata on the security function to be composed. For example, I don't know if there is a dot that is not there, how do we may replace that dot in the case that we need it, or similar things like that, right? On the other hand, we have also the dots discovery that is related to what I mentioned before on the registry, that is responsible for knowing what the status of a dot should be. Look, that a dot could be a tool, could be Prometheus, or a dot could be a functionality of a well-known tool, right? So we should find out also how we manage that internally in the composition process, and how we define which is the status, in the sense of how this tool is deployed, how this tool is used, how this tool is empty, or it's available for other security functions to use as well, right? And then we have the dots linker that would be the one that would create this say the composition of dots to create the security function, right? So and that's the idea. So then finally, as a demo strategy, we are, as I said before, we have these 11 POCs. We are proposing a layout, a validation layout that is built on simulation, emulation, and real infrastructure. On simulation, we are using traditional, say, well-known and traditional, well-known simulator software. On emulation, we will leverage network digital twins. On real infrastructure, we have testbeds that are also provided by the consortium. So at the end of the day, what do we plan to have? What we plan to have is first to analyze the threat landscape, because I said before, I mean, the attack surface is something that is up and running, and it's not static, it's dynamic, it's not deterministic, it's completely open, as long as new technologies have been adopted by the 6G systems. So these new technologies for sure, and new, say, strategy on how to manage that will open the door to new vulnerabilities. So these new vulnerabilities will open the door also to new attacks and incidents. So we should find out the way to be more concrete on how we can manage this threat landscape. The second one is the security functions. I mean, this is something that could be quite useful because we can go for a reactive approach and a proactive approach very easily. We can even manage non-known attacks that may happen, I mean, in the system, and we may create specific, say, high-level security functions based on foundation models that can create a, say, by default, call it that way, by default security function that could be deployed in case that a new attack is popping up. Then we are creating this sort of pre-assessment environment that is an extension of what we did in Horse, and that it's analyzing the impact. It's analyzing the impact on the solution itself. It's analyzing the impact on the attack itself. It's also analyzing. It's also used for prediction. And then, of course, being that a security plane, so something that is completely abstract, is something that is completely softwareized, programmable, modular, open, dynamic. I mean, we can theoretically, as long as we have the right APIs or the right connectors, call it connectors, we can deploy this idea to any of the components that in the final 6G architecture would need to deploy security. And that's it. Thank you very much. I mean, any question, please just contact me or open to discuss.